Hey guys, welcome back to my YouTube channel. Hope you are all doing well. We will continue our series of nerve muscle physiology, and in this video we will cover all the concepts of action potential and voltage gated sodium channels. So let's get started. This action potential is the rapid sequence of changes in the voltage across a membrane. Only neurons and muscle cells are capable of generating the action potential by the property of excitability. Let's understand this concept by means of a graph. From x-axis we will see the time duration in milliseconds, and from y-axis we will see the membrane potential in millivolts. We should remember this membrane potential is calculated by means of microelectrodes. We should also remember that the resting membrane potential of a neuron is minus 70 millivolts. Let's start the beautiful concept of action potential by giving stimulus to a neuron at a particular point. After giving stimulus, the neuron will not immediately respond, and there occurs a bit delay in the response, and this delay is called the latent period. This action potential can be divided into four phases. Firstly, there occurs the local potential change, then there is the depolarization, then there is the repolarization, and at last there is hyperpolarization. In local potential change, the membrane potential changes from minus 70 millivolt to minus 55 millivolt. This is due to the slow influx of the sodium ions. There is the sodium influx. In depolarization, there is rapid increase in the membrane potential, and the membrane potential increases from minus 55 millivolt to plus 35 millivolts. This is also due to the sodium influx. But here the sodium influx is very fast due to the presence of voltage gated sodium channels. In local potential change, there is also sodium influx, but there is no voltage gated sodium channels, and there is slow influx. In depolarization, there is the sodium influx, but here it is fast due to the presence of voltage gated sodium channels. Coming to repolarization, the membrane potential drops from 35 millivolt to minus 70 millivolt due to the efflux of potassium ions. Even after reaching the resting membrane potential, that is the minus 70 millivolt, the potential further drops to minus 90 millivolts, and it leads to the phase called as hyperpolarization. We should remember this hyperpolarization is inhibitory to the neuronal functions. But now the question arises, how does this hyperpolarization occurs? It occurs due to two reasons. Firstly, the slow closure of potassium channels. The potassium continues to efflux even after reaching the resting membrane potential. A second reason is the influx of the chlorine ions into the membrane. Can we name any inhibitory neurotransmitter? Absolutely. GABA, which is an inhibitory neurotransmitter, leads to hyperpolarization. Now we must understand two very important concepts, accommodation and adaptation. Let this be the threshold stimulus, it will generate the action potential. The stimuluses above the threshold stimulus, called the suprathreshold or the supramaximal, also generate the action potential. But by giving suprathreshold or supramaximal repeatedly, there will be also no generation of action potential, and this phenomena is called as adaptation. And the stimuluses below the threshold stimulus are called as subthreshold stimuluses. These subthreshold stimuluses do not produce any action potential even if we give repeatedly. No action potential. Even if we repeat, there will be no action potential. And this phenomena is called as accommodation, because summation is not possible in action potential. Now let's see some of the difference between local or graded potential and action potential. Firstly, amplitude change when the stimulus intensity changes in graded potential, while in action potential the amplitude is independent on the stimulus strength and it always remains constant. Secondly, it does not follow all or none law, but we know in action potential all or none law is followed. Here in graded potential the summation is possible, but we know summation is not possible in the action potential. Here in graded potential, threshold is not required, but we know in action potential we require a threshold stimulus. End plate potential is an example of graded potential. Now we will see the absolute and the relative refractory period. The absolute refractory period is from the firing level to 1/3 of the repolarization. Here the voltage gated sodium channels are in inactivated stage. They can't be opened by giving the maximum strength stimulus, hence AP generation is not possible here. Relative refractory period is from 1/3 of the repolarization to the end of hyperpolarization. Here the voltage gated sodium channels are in resting stage. They can open during maximum strength stimulus and hence can generate the action potential. Now we will see the gate concept. Consider this membrane containing the sodium channel. This sodium channel is voltage gated. It shows two important gates. Two important gates. The first one is called as M gate. It's also known as activation gate. The second gate is called as H gate. It's also called as inactivation gate. We are going to see the three important states in which this channel can exist. The first one is called the resting state or the closure state. In this state, the M gate is closed and the H gate is open. Can sodium influx occur here? No, sir. Why? Because the primary gate or the M gate is closed, so any influx cannot occur here. But we have seen earlier, if we give maximum strength stimulus in the resting state, sodium influx can occur here and generating the action potential. The second state is called the open state, in which both the gates are open. M gate is also open and H gate is also open. Here any influx can easily occur. The third one is called the inactivation state. Here the M gate is open while the H gate is closed. Can sodium influx occur here? Any influx? No, it can't occur here. Even if we give maximum strength stimulus, the sodium influx can't occur here. So guys, this was all for today. Hope you liked the video. Comment down below if you find anything useful in the video and share it with your friends. Like and subscribe if you have not already. Have a nice day. Bye.